The overall goal of this experiment is to study the effect of carbon dioxide dissolution on the rheology of crude oils.
When CO2 is injected into an oil reservoir, it dissolves into the crude oil. This can strongly affect the oil rheology, a crucial parameter in predicting flow in the reservoir.
The main advantage of this technique is the thorough measurement of the rheology of a gas-liquid mixture at reservoir conditions, answering the fundamental question whether the mixture is Newtonian or non-Newtonian.
To begin preparing the double gap geometry pressure cell system, disconnect and open the high pressure mixer. Load a stir bar and 200 milliliters of low viscosity oil into the mixer. Close the vessel with screws and reconnect the mixer. Remove the pressure head and measuring cylinder from the pressure cell. Ensure that the valves to the gas tanks are closed. Close the oil and gas valves connected to the mixer, the gas valve to the pressure cell, and the gas relief valve. Open the relief valve on the recycle path of the circulation loop. Then, open the mixer to nitrogen gas. Once the gas reaches the mixer, close the nitrogen valve and cylinder. Open the oil valve downstream of the mixer and monitor the double gap geometry. Once the inner part of the double gap geometry is just barely immersed in oil, open the gas relief valve to depressurize the system. Start the gear pump and adjust the rotation.